Okay, done. So the yeah, quiz number 4 due date has been shifted. This is okay. I since I have time, I'll entertain you. Okay, so been shifted to October 22nd. So I'll change the date down here. Okay, I'll change for you, just for you guys. October 22nd. Okay, just for you guys. I'll change it after class. Okay, stop distracting me, you cheeky sod. Okay. Yeah, stop distracting me. Okay, we have to focus here. So that is mode number 1. And mode number 2 is the shear stress is equal to VQ over IT of the wooden structure. Okay. So this is mode number 2. Okay. So let's look at mode 1 first. Okay. But before we look mode 1, we are going to construct our free body diagram. Okay. So this is point A, point B, okay, AY, BY. We have a load down here that is P, and the distance from here to here, and here to here. So this is equal to it's 4 feet. So you have to convert to inches. Okay. So we know we're going to take our moment. Okay. Sorry, I don't think we need to take moment because we only going to find our shearing stress. Okay. So we just need the shear force. So shear force is equal to so let's do properly. Okay. So if this is X, this is Y, rotation about Z. Okay. So positive is going up. Summation of forces in the Y direction is equal to 0. AY plus by BY minus P is equal to 0. We know that AY is equal to BY based on symmetrical geometry and loading about the y-axis. Okay, so therefore AY is equal to BY is equal to P over 2. Okay, so this is our Vmax, the maximum shearing stress that we can find. Okay, now I'm not going to calculate the second moment of area. Okay, but I'm going to give you that the second moment of area is equal to 2902 inches to power 4. Okay, I believe all of you know how to calculate second moment of area from this diagram. Okay, you all want me to show you or no? Okay, I will show you then. So to calculate the second moment of area quickly, I just take the outer box minus the inner box. So the width is 7. The depth is 10 plus 2 plus 2 14 plus 2 plus 2 18 cube power of 12 minus by the internal box, which is 6, multiply by 10 cubed divided by 12. Okay. So this will be equal to 7 times by 18 power of 3 divided by 12 minus 6 times 10 power of 3 divided by 12 is equal to 2902. Okay, shown. Okay. So now we are going to find out about the mode 1 failure. Of the fastener. Okay. So we know that Q is equal to resistance force divided by spacing. Right. And this will be equal to, so the resistance force is 600. Right. Then we have the spacing is 6 inches. We have to multiply 2 over here because of double shear. Right. Remember I explained to you. So we have double shear configuration, right? So remember double shear configuration for double shear. Hey, best. So double shear is equal to P divided by 2A, right? So P is equal to the hey, what am I doing, man? Eugene, come on. Right. So this shear is constant, yes or no? Right. This is also constant. Right. So that's why we have to double the area. Or not double, you have to multiply by 2. Okay. So 600 times 2 divided by 6 is equal to 200 pound inch. Right. So the tricky part is now we know that Q is equal to 200 pound per inch. And this is equal to VQ over I. Right. We know I. We want to find V. Okay. But what is Q? It's always the first moment of area that is going to cause you the trouble. Okay, what is Q? So this is where you start drawing your shear flow again. Okay, it's not exactly the same like thick and thin wall, but the shear flow can help you. Okay, to visualize. So if this is your V, right? So your Q will go on this way. Right? And then your Q will do this. Right? So when you see this, the fastener will transmit the shear flow from the flange to the web. And where it's going to fail, right? It's going to fail here and here, here and here, right? So if this is our centroid, right? The analysis can, or the first moment of area cannot cross the centroid, yes or no? The area to be determined is this area I'm shading now. Just for the flange. So when that's the case, right, Q is equal to width multiplied by depth multiplied by y bar, right? So width for this case is 6, depth is 4, y bar, so 10, 14 minus by 4 divided by 2. Okay, so this is equal to 14, so it's 12 times 4 times 6 is equal to 288. Okay, hold on. 4 divided by 2. Oh, no, I got this wrong. It's not 4. It's 5 plus 2 plus 2, 9. Plus by minus by 4 divided by 2. So 9 minus 2 times 4 times 6 is equal to 168. So now we got this, right? You apply that Q is equal to VQ over I. So this is 200. V, we know that's P over 2, right? Q is equal to 168. I forgot what's I. 2904. Or 290, is it 2904 or 2902, sorry. Therefore, P is equal to 200 times by 2902 times by 168 divided by 2. Yeah, 200 times by 2902 divided by 168 times 2 is equal to 6909909 times 10 to the power 3 pounds. I just lost my mindset of the unit for force in imperial. Okay, so this is due to fastener. Okay, so this is straightforward. Okay, or this is what you learned today, right? Or now, okay, to find the failure at the joints. Okay, and the next one we are going to find is the mode 2 failure. Let me see, can I say space? Okay, I can say space. So I'm going to do halfway. So mode 2 failure is failure of the wooden structure. Right? So if I'm going to copy this image there. Right? So we're going to have the failure at the centroid now. Okay. Some of you might say, Eugene, thick wall or thin wall. Does not matter at the centroid whether thick or thin wall does not really matter, does it? Okay. So now we have our first moment. So again, our first moment of area. So Q. So Q, we found the Q at the flange to be 168. Okay, 168. plus. Now 168 is only for this region. Yeah, it's only for this region. Okay. So this one you have to multiply by twice, left and right.